to this video. As you can see, what we're going to do is have a look at sketching a line given its equation. Now, you have done this before, so I'm hoping this will be a review. So what I'm going to do is just outline the key things I'd like you to do when it comes to sketching, and we'll look at some of the more unusual examples as well that you might come across. So first of all, to be able to sketch a line, you absolutely need 2 points to be able to sketch. So if I give you 1 point for that line, there's no possible way that you can draw the particular line that we need. So having said that, when you do a sketch, make sure that 2 points are clearly labelled on that line. To sketch, obviously your line passes through an infinite number of points. So the actual 2 points that I'd like you to show when you sketch are the X and Y intercepts, so the coordinates of the X and Y intercepts. Now, of course, this isn't possible if, say, you've got a vertical line. Obviously, if you've got a vertical line, it's quite possible it's not going to pass through the Y axis, so it doesn't have a Y-intercept. Likewise, a horizontal line likely will not pass through the X axis. Except, of course, it's sitting directly on the axis. So in those cases, I'll show you what you need to do. And there's another case, and that's if the line passes through the origin, the point 0, 0. That obviously means that the X and Y intercept is the same. So you've only really got 1 point in that case. So I'll show you what to do when you have something like that. So the key thing to remember if you are looking for X and Y intercepts is that you want to consider what value the X or the Y will have at that particular intercept. So as an example, the X-intercept, that's always going to happen, that's always going to occur where Y is equal to 0. Now the reason is, if I do a quick little sketch here, of course the Y-axis is here, X-axis is over here. So if I want to know where my line is touching this axis here, obviously that's where Y, this axis, is equal to 0 always. So all I need to do is substitute into the equation Y equals 0. I will then solve and get a value for X, and that is my X-intercept. And then I'll state that particular coordinate with the obviously Y is 0, so you have your X value, comma, 0. The opposite is true for the Y-intercept. So if you have a look, Y-axis is this one here. If I want to know where the line is touching along this axis, that's essentially what the Y-intercept is, that's where X is equal to 0. So I will substitute X equals 0 into the rule and therefore generate my Y-intercept. Now I just want to make a point about the Y-intercept, and that's if our equation is in the form Y equals mx plus intercept is easily readable off the actual equation. So I mentioned that B in this particular form is the Y-intercept, and that's because if you substitute 0 in for X here, you're going to have Y equals B. So the Y value, now the Y-intercept value is always going to be B, but only when it's in that form. Remember, when it's in the general form, you can't actually read it straight up like we can with this particular form. I'm going to show you a few to have a go at, so I'll just flick through to different slide. And here we have a couple. So the one on the left is in that gradient intercept form, the one on the right is not. So I'll show you what we can do with that. So first of all, this one here, A, sitting here on the left-hand side. What we can see is it's in that form Y equals mx plus b. So what I can do is I can read the intercept straight away. The intercept, or the Y-intercept, is happening at 5. So that gives me the coordinate. I'm just going to fix this, sorry. That gives me the coordinate for my Y-intercept. I'll just call it Y-int, is 0, 5. So that gives me one value already. So on my axis down here, I'll just label it as Y and X, of course. I've got the point 0, 5, so I know the line passes through this point here. I'm just going to call it 5. The second thing I need to do is work out what my X-intercept is. So to get the X-intercept, we sub in Y equals 0. So that's what I'm doing to get this answer. So 0 equals negative 3x plus 5. So of course 3x equals 5. That gives us x is equal to 5 on 3. So the coordinate is 5 on 3, comma, 0. So y value of 0, x value is 5 on 3. So it doesn't matter where I put that on this axis because I'm just going to show 2 points. So I'm just going to choose a random spot just here, label it as 5 on 3, and then I'll connect these two with a straight line. I might just go with a pink one, like so. And to finish it off, I'll clearly label these 2 points. So this one was 0, 5, and this one down here is 5 on 3, 0. So notice that we have a negative slope or a negative gradient, and that's expected because have a look up here, we've got negative 3 as our m value. So there's our first little sketch. Moving across to this one here, as you can see, I can't as easily just read off the y-intercept. So what I'm going to do this time is make sure I follow the steps that I discussed before. So first of all, for the y-intercept, we sub in x equals 0. Just putting in brackets what I'm actually doing. So when x is 0, this is going to be 6 by 0 minus 3y equals 18. Now I'm just going to keep this to the left-hand side because I'm worried about space here. So this leaves me with negative 3y, of course, because this just cancels out as it is 0. So y will be 18 on negative 3. So that's negative 6. So that's my coordinate for my x-intercept, sorry, my y-intercept. That's when x is 0. And so that's going to be down here in the negatives. I'll go negative 6 just there. I'll just split this into 2 so that I'm working down the page. There we go. And now what I want to do, the opposite. I want the x-intercept, therefore y equals 0. There we go. Back to the white colour. All right, so 6x minus 3 times 0, so that's just going to cancel out there, equals 18. So 6x equals 18. So x is obviously 18 on 6, which is 3. All right, so x is 3. There we go. I might just put these on as I missed them before. I will now connect with a straight line. And of course, label the points. So this one here, 3, 0, that's what I got here. I'll just write my coordinates. And this one was 0, negative 6. So there's my second line. So as you can see, a fairly straightforward process, provided that we always recognize y-intercept occurs where x is 0, x-intercept occurs when y is 0. Do a couple more, so just moving to my next slide. So here we have an equation in general form on the left-hand side there, but no need to worry because we do exactly the same thing. First of all, let's get our y-intercept by making x, or by equating x to 0, so substituting x is 0 into the rule. So 8 by 0 is 0. We're going to be left with negative 4y plus 20 equals 0. Okay, so we can now subtract 20 from both sides. Y is then going to be negative 20 on negative 4 and of course that is equal to 5. So down here, I'll call that 5, y, x. I haven't left myself a good amount of space here, unfortunately. That's okay. I might just move this over a little bit. So I won't need as much space for that one. All right, so of course I've got my y-intercept, now my x-intercept. X-intercept, we equate y to 0. Split this in half. All right, so 8x minus, well, it's minus 0, but to show you fully what I'm doing. There we go. So 8x plus 20, as this bit just cancels out, equals 0. So 8x equals negative 20. Subtracted 20 from both sides. So x is equal to negative 20 on 8. And we'll simplify. So it goes into negative 5 on 2. Of course, common factor there of 4. All right, so negative 5 on 2 is going to happen on this negative side. So negative 5 on 2, we just have to mark it. You see I don't bother putting a long-winded scale down or anything like that. I just need to clearly show the 2 points. So you just need to mark them anywhere on the axis, really. Just make sure it's on the correct side of the axes, positive or negative side, of course. And then clearly label them like I'm about to do. So I probably should have done this before, but my final coordinates were these. And then that's, of course, what I'm labeling on my graph. Okay, now, if you have a look at the next one, you'll see it does look a little bit different to the ones I've been doing, only because you'll recognize it is in the form y equals mx, but because there's no b value, there's no constant term at the end there, what this means is our b value, our intercept, must be equal to 0. So when you see them in this form, so they're basically in the form y equals mx, what this means is you actually have a y-intercept occurring at 0. So our intercept is occurring through the origin. This, of course, means that our x-intercept is also at the origin. Because if it is passing through the origin, it's passing through both x is 0 and y is 0. So through there. Now what this means is if I know the point goes through there, it means that I can't show 2 different axes intercepts as I would like to. So what you need to do in this case is you need to select another x value. So I'm just going to choose when x equals 2, y equals 4 by 2, so y equals 8. And the reason I'm doing this is just so I can establish a second coordinate. So the second coordinate I've got is 2, 8. So if I just go, all right, that's going to happen here. And get my line, rule it through the 2 points. Make sure I label this as 2, 8. It's my second point. And what you can also do is just mark it on your axis as well. So this is where x is 2, and this is where y is 8. So once you've got that, we still have a line that has 2 coordinates shown. Like I said, you always have to have 2 coordinates shown. Okay, just one more special case, and that is when you're equations look like this. Now, we have touched on these sorts of rules before, so hopefully you remember when we have a rule that is in the form x equals, and then you have a constant term, so x equals a number, what you're dealing with is actually a vertical line. Now that vertical line is going to pass through, so your x-intercept is going to be whatever this constant term is equal to, so it's -2. And so I'm going to get my line, make sure that it's vertical. You can try and get it more accurately through the line. There we go. Now what you can do is select any other point that's going to be on that line. So the x value here is -2, y value is 0. Now wherever you are along this line, the x value is -2, and it doesn't matter what the y value is, so let's say it's 2. Because wherever you move along that line, positive or negative, the x value is what remains the same for any value of y. We can label it as well. Oh, now that's one thing that I have forgotten in terms of my line. I have not labeled them, which is very silly of me. If I go back to this one, it is, of course, conventional to write the rule for the line, especially later on when we start graphing more than one line on a Cartesian plane. It's a good idea to get in the habit of labeling it. So my apologies, you'll have to just go back to these examples that are in your workbook. Let's fix this up a little bit. So that was so just quickly jot them down. I haven't left myself a whole heap of space, unfortunately. And that one's y equals 4x. Okay, so getting back to our special cases that I had before, we've now done the vertical line. And of course, when we have a line that looks like this, or an equation that looks like this, as you can see, obviously we're working with a horizontal line. So all you need to do is have a look at what that y value is. That's telling you the intercept. It's telling you, in fact, where on the y-axis that line, that horizontal line is located. So like that. Pick any other point along that line and label it. So this would be x is 0, y is 3, and say x is 5, y is 3, something like that. And we'll label it y equals 3. So really the horizontal and vertical lines are probably the easiest ones to plot. Now one more thing for this video, and that is to look at just different case, I guess, of what you can come across. Questions like this. So if you've got points that lie on a particular line with this equation, finding what that y or x value might be in the coordinate. So here you're recognizing that when you have a coordinate and you substitute those values into the equation, they will satisfy the equation. So that means that the left-hand side will equal the right-hand side of the equation. I'll show you what I mean. This one here, we've got the x value of 0 and the y value of a. So what I'm going to do is I'm going to substitute those two, either number or pronumeral, into this rule. This first one I'm going to have is 5 by 0, because it's 5 by x, minus 4 by y. Now that's actually 4 times a, if we substitute the y for a, and that's equal to 20. So what I'm left with is negative 4a equals 20. Therefore, a equals 20 on negative 4 Now I've sort of lost my negative there. It looks like it's underneath the equal sign. So I don't really like that too much. So try and make it a little bit clearer, like that. And that will be equal to -5. So I was just asked to find the pronumeral, and the pronumeral in this case is -5. I'm asked to find the pronumeral in this case, which is f, so I'm going to go 5 by f, so substituting the x for f, that's x, that's y, minus 4, in this case 10. Alright, so 5f minus the 40 equals 20. Add the 40 to both sides, 5f equals 60. So f is 60 on 5, which is 12. So there's my answer, f equals to 12. So there's a little bit of practice with a different kind of question that is, I guess, testing your conceptual knowledge of the equations and the lines. I will stop there with this one, and I'll obviously see you in class to work on these.